let's do it. So it's ready to be built, and that means all our code is ready to be executed because we don't need to change anything more. So let's execute the sections one by one, and let's see what happens with decision tree regression. So I'm going to select the first section, execute, dataset 1 imported. Here it is. All right, so then no need to split the dataset into a training set and a test set because, as you can see, this is a very small data set. Then no need for feature scaling because for decision trees, we don't need to do any feature scaling because the way this model is built is based on conditions on the independent variable and not on Euclidean distances. So we're fine with that. We definitely don't need to apply feature scaling, and we can move on to the next step, which is to create our model. So let's create it. Executing. All right, perfect. Regressor is created. And now let's get our final verdict. Okay, so 160K according to this person. And now let's see the predicted salary according to our model. So executing this, and we get a $249,000. Wow, much higher than the salary mentioned by this person. But let's not drop hasty conclusions, and let's see what's happening on the graph here. So I'm going to select all this, and let's see what's happening with the decision tree regression results. All right, that's what I thought. Okay, so we don't need to zoom on it. We clearly see what's happening here. It's plotting a straight horizontal line, exactly like we saw in SVR, but for Python. For those of you who didn't follow the Python tutorial, know that we already encountered this situation when we get a straight horizontal line. And actually in SVR, this was due to the fact that we didn't apply feature scaling to our dataset. So what do you think the problem is here? Do you think it's due to the fact that we didn't apply feature scaling like for SVR, and we need to apply feature scaling to get a model fitting properly the dataset? Well, as I mentioned in the beginning of this tutorial, we definitely don't need to apply feature scaling for decision trees because decision tree regression models are based on conditions on the independent variable that has nothing to do with Euclidean distances. And, when we need to apply feature scaling, it's because the machine learning models are based on Euclidean distances, and we need to put all the independent variables on the same scale so that one independent variable is not dominating another one. But this is not the problem here. This is not about feature scaling. You can try to apply feature scaling here and re-execute this, but you'll get the same problem with a straight horizontal line. And of course, this is actually the decision tree model. This is actually one model of decision tree, but this is of course not the best version of decision tree regression we want to get. So can you start seeing what's the problem here? And especially after watching the intuition tutorial made by Kirill, can you spot the problem? Okay, I'm going to tell you this problem is related to the number of splits. Because, the way the decision tree regression model is made is that it's making some splits based on different conditions. So the more conditions you have on your independent variables, the more you have splits. And here, we clearly have no split here because, all the predictions are equal to $250,000. So, it took all the different salaries for the different 10 levels here and made an average and just gave the average for all the levels. So no conditions here, no splits, and therefore that's absolutely not interesting, especially for the potential that decision tree can have. So what we'll do now is add a parameter here that will set a condition on the splits. That's what I was telling you. We have several parameters in this RPAR library, and we can use these optional parameters to improve our model and make it more robust. Well, this is exactly what we're going to do now. We are going to get back to RPAR. So I'm going to press F1 here. Oh, actually, this time RPAR is showing up. Okay, so great. RPAR is here. And as I mentioned, RPAR has several parameters that we can use to make our model more robust. And the one we're interested in right now is one parameter that will correct this problem we had with the splits. So this parameter is actually the control parameter. And right now I'm going to give you a little trick to solve this problem on the splits we had just obtained here. So I'm going to add this third optional argument, to improve our model. Right now we're doing some model performance improvement. So that's a thing that machine learning scientists do very often in their job. So don't worry, we'll get more advanced sections on it, especially when we cover cross-validations to find the best models, selecting the best parameters. But here we will just do some simple model performance improvement, and we'll just add this control parameter, and then I'm going to give you this little trick. So this little trick is to take the rpart library again. So we're taking rpart control here, which is a function. And in this function, we're going to add an argument. As you can see here on this yellow rectangle here, we have the first argument that is min split. And that's exactly what we're interested in. And that's what will solve our problem. Because, actually we didn't have any split here because it just took the average. So it's like we had no conditions on the independent variables, so no splits. So to make sure we have some splits and some conditions on the independent variables, we will actually set min splits to 1. And that will solve the problem.